Imagine, the year is 1971. The room hums with computers as massive as wardrobes. Between two such machines sits engineer Ray Tomlinson. He has just created code capable of sending text from one computer to another over the ARPANET network. For testing, he doesn't type anything profound. He simply slides his fingers across the top row of keys, producing a random, nonsensical string of letters, something like QWERTYUIOP. He presses send, and the message is delivered. But the most astonishing part isn't the delivery itself. He immediately forgot what he had typed. Forever. This seemingly meaningless message is arguably the most important in digital history, and its loss changed the world. You're about to understand how. Today, we send over 300 billion emails daily. This forms the bedrock of business, friendships, and our entire digital lives. Yet, it all began with a message its creator considered junk, so insignificant that he didn't bother to remember it. For scale, consider this. The volume of emails sent daily is 1,000 times greater than the total number of letters delivered annually by the world's postal services at their peak. Every single day, we generate a millennium's worth of paper correspondence. All of this grew from one forgotten word. This is a story about technology's central paradox, how an act of forgetting spawned an era of total communication. We won't just recount this history, we'll uncover the very code of this revolution. You'll discover why Tomlinson was instructed to keep his invention under wraps. His work was funded by the U.S. Department of Defense through its ARPA agency, whose goal was to create a network resilient enough to survive nuclear war, not a chat system for scientists. Email was an unauthorized experiment, a direct violation of protocol. We'll reveal the ingeniously simple hack he used to create your email address and why he chose the @ symbol. And we'll tackle the central question: was this a stroke of genius, or merely an inevitable accident that could have happened to anyone? To truly appreciate the brilliance of that moment, however, we need to take a step back. Let's immerse ourselves for 60 seconds in a world without an inbox, without a reply button, a digital chaos desperately in need of order. Arpanet was a network for scientists, but it suffered from a massive communication problem: utter chaos. Imagine having a phone, but you could only call phones identical to yours, and only if they were plugged into your home outlet. Scientists could exchange files, but to leave a message for someone, you had to connect to their specific computer and leave a note in a special file. This file was often simply called a mailbox, or M-box. Essentially, to send a message to a colleague at another university, you had to remotely access their desktop and stick a digital note on their screen every single time. It was the digital age of foot messengers, and it was terribly inconvenient. Tomlinson had two distinct tools. The first was SNDMSG, a program that allowed users to leave such notes for others on the same computer. The second was the CPYNET protocol, which could copy files between different computers across the network. It's crucial to understand, SNDMSG was a program for people, while CPINET was a protocol for machines. One spoke the language of messages, the other the language of files, and these languages didn't intersect. No one considered making a file-transferring machine speak the human language of short notes. They existed in parallel, like a hammer and a screwdriver, two different tools for different tasks. Now imagine your workday if you could only message colleagues on Slack or Teams who were physically sitting at your table. It was absurd. This was the digital prison Tomlinson aimed to break out of. He wasn't just improving a system, he was trying to bridge a chasm. The core problem was that SNDMSG only worked locally, and CPINET could only transfer entire files, not short messages. No one thought you could send a message to another computer. They only thought you could copy a file. It's like inventing a global shipping system for large containers, that's CPINET, but continuing to send letters within the city via a courier, that's SNDDMSG. It occurred to no one to place a small letter inside a huge container and send it across the ocean. The task seemed too trivial for such a powerful instrument. This was a mental trap that ensnared the brightest minds of the era. He had two pieces of code that did completely different things, and it occurred to no one that they could be crossbred. Until that very day. Tomlinson's idea was ridiculously simple. He thought, what if I take the code from CPYNET, which sends files across the network, and integrate it into the SNDMSG program, which creates messages? Essentially, he taught a note how to travel. He transformed a local message into a network data packet. This entire historical breakthrough amounted to roughly 200 lines of code. For comparison, a modern application like Instagram has tens of millions of lines. He didn't build a cathedral. He simply found the key to all doors. It was less an act of brilliant programming and more an act of brilliant copy-pasting. And so, he sat between two computers, one the sender, the other the receiver. He wrote his code, launched it. The system prompted for text. He wasn't thinking about eternity. He just needed to check if the packet would arrive. He typed QWERTYOIOP or something similar, pressed enter, then went to the second computer, checked the mailbox, and saw the string there. The irony is that these two computers, connected via Arpanet, which by then spanned the entire country, were in the same room, just 10 feet apart. The first inter-network message teleportation in history occurred within arm's reach. It worked. Let's view this through Tomlinson's own eyes. For him, it wasn't a historical moment. It was merely debugging. He wasn't thinking, I'm changing the world. He was thinking, okay, fix that bug. What's next on the list? Psychologists call this the curse of knowledge. Tomlinson was so immersed in the technical details that he couldn't grasp the revolutionary potential of his creation from an outside perspective. For him, it was just an elegant hack, not a Pandora's box he had just opened for all humanity. This is key to understanding why the message was lost. To its creator, it was simply one of hundreds of tests, an insignificant step. When Tomlinson showed his invention to a colleague, the initial reaction wasn't, wow. But don't tell anyone. This isn't what we're supposed to be working on. Their mandate was to build a network, not create applications for it. Email was, in essence, a side pirate project that might displease management. The invention was made, but one colossal problem remained. The system worked, but it didn't know who to send the message to or which computer. A universal delimiter was needed, a symbol that would separate the user's name from the machine's name. Tomlinson needed a symbol that would never appear in people's names or computer host names to prevent system confusion. He looked at his Model 33 teletype keyboard. Unlike modern keyboards, this was a bulky mechanical machine, and most symbols, the period, comma, slash, asterisk, were already reserved by operating systems or programming languages. He needed an outcast symbol, an unemployed character that didn't yet have a vital role in the digital world. He could have chosen a comma, a slash, a parenthesis, but all of those could potentially be used within names. He needed a clean symbol that would carry one singular meaning. And then he saw it, the @ symbol. It was perfect for two reasons. First, almost no one was using it. Second, in English, it already carried the exact meaning needed, at. The scheme user at host computer read perfectly as user at host dot. It's amusing that a symbol that became synonymous with the future was in fact a relic of the past. The @ sign is a ligature from medieval manuscripts that later migrated to accounting ledgers, meaning at the rate of. Tomlinson took a nearly forgotten commercial symbol and made it the key to digital identity. This was not a technological solution, but a linguistic one, simple, logical, and brilliant. The genius scale of this solution, 10 out of 10. Tomlinson didn't invent new code, he reinterpreted an ancient accounting symbol. He didn't hack a machine, he hacked language. And with this simple choice, he created a universal standard for digital identification that we still use today, from email to social media. This simple convention, user at host, became the very first network standard. It was so successful that all subsequent systems copied it. The solution was so intuitive and elegant that it became a de facto standard, later officially enshrined in Request for Comments, RFC documents, which are essentially the sacred texts of the Internet. One person's intuition became law for millions of machines. Your digital identity, your login in any system, is a direct descendant of that very decision made in mere seconds at a keyboard. The system was ready. Addressing worked. But how did this humble pirate project transform into a technology used by 4 billion people today? Very quickly, email became the #1 reason people wanted to use Arpanet at all. It was the first killer app in history, a technology so compelling that people were willing to adopt an entirely new world just for it. How quickly? A study conducted just 2 years later in 1973 revealed shocking figures. 75% of all traffic on Arpanet, a network built for computation, was email. People had constructed a supercomputer highway and were using it as a post office. They connected to the network not for remote access to machines, but simply to communicate. Email forged a new culture. It was faster than paper mail, but less intrusive than a phone call. It allowed time to consider a response and created a written record of any conversation. This is a classic example of Marshall McLuhan's theory. The medium is the message. What was written in the emails was less important than the email format itself. Its asynchronous and textual nature began to change how people thought, worked, and built relationships. For the first time in human history, it became possible to have a dialogue over distance in near real time, yet without being tied to that specific moment in time. And this culture quickly moved beyond the labs. In 1976, Queen Elizabeth II sent her first email, becoming the first head of state to use this technology. In the 90s, presidential candidate Bill Clinton made his email address public. What began as a technology for geeks transformed into a tool for global politics and commerce. Consider this. How many times have you checked your email today? This reflex, this digital habit, was born from that forgotten QWERTYUIOP. Psychologists liken this reflex to variable reward, the same principle that makes slot machines so addictive. You check your email without knowing what's there, an important message, spam, or nothing at all. It's this very unpredictability that compels us to hit the refresh button again and again. Tomlinson inadvertently created the world's first digital slot machine for information. Our dependency on the inbox, the stress of unread messages, all of this is a direct legacy of an experiment its creator deemed insignificant. But this revolution also had a dark side. In 1978, the first mass unsolicited email was sent, the first spam in history. It was dispatched by a marketer named Gary Thwerk, who sent an invitation to a DEC computer presentation to approximately 400 ARPANET users. The reaction was immediate and furious. Thus, alongside email, the fight against spam was born, a battle that continues to this day. The ease and low cost of sending messages also gave rise to the digital world's biggest headache. No perfect tool exists. So what can we glean from this incredible story, where the greatest invention began with an act of forgetting? There are actually 3 lessons, and they are far more significant than you might imagine. We've seen how brilliant simplicity emerged from the chaos of ARPANET. 2 programs glued together and a single symbol. How a forgotten message gave birth to a global communication network. And here's the first lesson from this. True innovations are born not from a desire to build something cool, but from solving a real, tangible pain point. Tomlinson wasn't trying to change the world. He simply wanted to make communication easier for scientists. In Silicon Valley, this is called the scratch-your-own-itch principle. Tomlinson himself said in an interview, "It wasn't a task. It just seemed like a good idea to me." Great products often don't begin with a business plan, but with a simple desire to make one's own life a little easier. He solved his own problem, and in doing so, solved a problem for everyone. Lesson 2. The most powerful solutions are often not the most complex. Tomlinson didn't write thousands of lines of new code. He combined 2 existing tools and reinterpreted a single keyboard symbol. Economists call this combinatorial innovation. Progress is driven less by new bricks and more by new ways of stacking them. Tomlinson didn't invent new Lego bricks. SNDMSG and CPyNet already existed. He simply was the first to figure out how they could be connected. A breakthrough is often a fresh perspective on old things, rather than creating something out of nothing. Lesson 3. The significance of a moment is defined not by the creator, but by the users. Tomlinson forgot his first message because for him it was insignificant, but the millions of people who began using his invention made it historic. This is like the story of Post-it notes. Their inventor tried to create a super strong adhesive, but achieved the opposite effect. He considered his project a failure until users found a brilliant application for it. The inventor doesn't decide what they've created. The world does. The legacy of an idea is more important than its birth. The story of the first email is one of how complexity and order are born from randomness and simplicity, and it leaves us with one main question. What was it, really? An act of brilliant insight from one individual, or simply an inevitable accident that was bound to happen in that environment? Write just one word in the comments, genius or accident. Let's see which gets more votes. Thank you for watching.